Alright, so today we're going over the basic inspection and operation of the 3D printer. This is currently the larger printer, the TAZ. And so mostly we're going over the physical aspects of the entire machine here. So first thing to make sure is, hey, over here, where my hand is, does it turn on? And so we've got a blue light up here. It'll give its whole spiel of, I'm a TAZ 3D printer. And that's good. If it doesn't light up, there's going to be a power supply problem, and if there's that, you're going to want to call a tech, pretty much. So, after it's come up, we've got our panel over here, and so, I'm not sure you can see it quite, but you can see temperatures, pretty much if there's an SD card in it, and later on, if you're adjusting the print manually, that's where you'll go. So, the real things to look out for are pretty much all in this section. So the first thing we have is basically the needle or the extruder. And on the extruder we have our filament going in. This is currently already in, but we will be showing you how to remove and pull out the filament. And so next we have our heated bed. Now normally when the printer is in operation you will not be touching this plate because it will be 100 degrees Celsius, and that would be extremely bad. For prolonged contact. But the bed has to be correctly leveled in order to print correctly. And so for the bed we have 4 corners, and each of these corners there are 3 screws. There are 2 that manage how high it is up from the metal plate, and 1 that secures the actual heated bed. The 2 that are the spacing screws, or the leveling screws, are the most important. Because if the bed is not level, we will not get a print. To level a print, you must first remove the locking screw, which as you can see in this corner, is on the bottom of the bed. And this allows you to adjust the corner up and down. On the far side, actually over here, is another hex screw, which is attached to a spring, and that is your actual leveling screw. So adjusting it left to right, tighten up and down, will give it an up and down effect. Normally this should already be leveled, but this is something that anyone can do by observing the filament, which we will do later. And so, if we come in closer here, we actually are going to look at the bed now. And so on top of the bed we have what's called a film, or a Kapton tape. And so ideally there are not going to be as many wrinkles as there are now, but wrinkles are always a factor. But this is a heat resistant tape that allows for the adhesion of the filament to the plate. Also on this plate, as after the film is down, we can put a glue stick, run it back and forth over until the print area is liberally glued, and we'll be printing on top of the glue and it'll help with adhesion. And adhesion is a big thing because items can slip off during a print and cause a whole print failure. Okay, I believe next we'll go on to how to operate the extruder, and we'll actually need to heat it up for that. Alright, now we're going to go over the operation of the extruder here. And so currently, if you look at the top left plant, it is at 230 degrees Celsius. That will instantly destroy skin basically if you touch it. So please do not touch the metal needle. So first off I'm going to clear the nozzle here. And so this is a good sign that we're actually already loaded and extruded. But we're going to go over how to take out and put this entire bit of wire in. And so on the first side here we have what's called our tensioner. So this is a 2-piece mechanical setup which latches the filament into place against the extruder gear. And so this is the motor that drives this gear inside, which catches with teeth in the gear to push down the filament through the nozzle to extrude. And so on our left here we have 2 turning knobs, and so this is to adjust the tension on the filament. And so if you find that your filament is slipping or if it's grinding out midway, you may want to increase the tension by screwing these in. Or if you find that you can't latch it back, as we're about to show you, you may want to unscrew them. So the first thing we're going to show you is, since the filament is already in, is how to take out the filament. And so that is done by lifting these tension screws up, and you can put your thumb on the little ledge here and pull back. This goes up and the tensioner gear falls out. And just like that, you can take a hold of this, pull slightly left to get out of the gear here, and you can pull it up and you can just remove it. And that's about it, at least for taking out filament. Now, assuming that we're putting on a new roll of filament, we've threaded it all the way through back on our tube, we're going to do this same operation in basically reverse. So, what you're going to try and do is take your edge of the filament, make sure there isn't basically a half moon carving out of it on the right side here. If there is, you're going to want to cut off the section, but we're fine right here. We'll show you an example of the cut filament. You can see right up in here how it is basically a half moon shape that got carved out of it. And so if the filament ever stops extruding from the machine, or basically it just stops, probably this is what happened. And so you'll have to take out the filament bit, chop it off, reinsert it, and basically probably adjust the knobs again. But what we're going to do is find the hole that goes all the way down to the metal extruder, which is about in the middle, right next to the gear here. And we're going to thread it all the way down, basically until we reach resistance. And by the way, you only want to do this when the actual extruder is hot. Otherwise, you're not going to be able to pull it out or put it in. And so, now we're going to do basically the same thing again. We're going to lift up our tensioners, and we're going to put the gear right back in. Make sure it fits into the slotted filament slot, otherwise it's going to pinch it. And then we're going to hold it, put our springs back to normal. And see, I actually cannot move this back, so I will have to undo tensioning. And then try again. And now we've slipped it back into place and filament is loaded. Alright. Trying to learn how to use the 3D printers, and so what we're going to be going over today is how to connect to the 3D printers interfaces and web servers that we have hosted on our Raspberry Pis. And so, starting off, basically, the Raspberry Pis are 3D printers are hosted on Raspberry Pis, and so that means we can connect to them over IP with bookmarks and addresses that are taped to the top of the printers. So in our case, we already have a bookmark for our TAZ Octoprint, and so Octoprint is the interface we'll be using. And hitting our bookmark, you see we go to an address up here in the top left, 10.31.94.246. And so this is just like if you're connecting to one of our OpenROVs. This is the IP address of the Raspberry Pi that is hosting our web server. And so you've seen this nice interface come up in the center. First thing that we're going to have to do is just take it all in. And in the top right over here we have a login button. So basically this is a user access control. You can't use the printer if you don't have a login. And so the login is just our simple, same as logging into our regular laptop. Student. And we're not going to save this because hopefully people that we don't want on will be on. We're going to ignore this update for now, but if you do see this, always hit update. So, going on, first thing we've noticed is, hey, we've got a number of things on our screen. So at this point, we are connected to the Raspberry Pi, but the Raspberry Pi is not connected to our 3D printer. And so up in the top left, we have this giant connect button over here. And so this will appear again if we're not connected. And so we're going to hit connect, and we're going to observe our 3D printer. So this is the TAZ printer again, so the bigger of the printers. And if you watch the LCD screen while it is connecting, you can see it reset, go to the TAZ logo, and then be back. And so in just about another 5 seconds here, it'll be connected. And here we go. Yep. when this goes all the way back up, we are connected. We can pull it back up, and you get the big disconnect button if you need to, etc. Moving on, now on the right side here, we've got our temperature graph. So this is the temperature of both the bed and the extruder needle. As you can see, there's a little legend right here. In red is the actual temp and actual bed. In faded colors are the target temps and whatnot. We'll be going over this in a bit. So basically, basic operation is uploading a file and then setting the file to print. We're going to go over uploading a file currently. And so right now, you can see over here we already have 2 files loaded. We're going to go and we're going to download a file and upload a file directly. So where are we going to get a file? We're going to go to Thingiverse. And so we already have one nicely selected out here. And so this is for our irises, longer legs, so we can put gimbals on them. Makes sense that we should have them. You can read summary, etc. But the real thing we want is either going to be the download all files in the top right, or if we want a really specific file, we're going to go in the middle here. There's a thing files right here. And so we're going to go for, there's the long leg mount, and I think we're going to go for the tri-leg V2. Alright, and see we've downloaded it in the lower left here. We're going to show in folder to pick it up. And so we're going to go back to our Octoprint actually. And so there's 2 ways we can actually upload it. We can upload it by hitting the giant upload button in the bottom left, and that'll bring up our general uploader, etc. And we can find our file, hit open, let it go. Or we can just bring up our file, move to the side, and if you drag it into the left side of the screen, you'll see, hey, we have an upload locally option. So we're going to drag and drop it in there. And you saw it was saving, and now we've got this window that pops up that says slicing. So slicing is the act of taking one of our 3D models and making what's called a toolpath, or a G-code file. So this is the path that the needle actually follows and extrudes to make the entire object. So we have our slicer Cura engine, our slicing profile. So if we wanted something specifically made, really light or otherwise, we would upload a specific profile for it. The TAZ 5 brim and support slicing profile is generally what you will use when you're looking for something that's just default, you want it made quick and good. So printer profile is the default TAZ leg after slicing. So this is kind of the option that you'll be checking off if you're doing this. And so there's the do nothing, there's the select for printing, and then the start printing. The TAZ is configured that you can just hit start printing and go to slice, and it will take off and do it for you. So long as you've done the physical setup and the physical calibration, that's perfect. You can leave it at that. However, we're going to be going over the full operation today, so we're going to hit select for printing. Just keep in mind, if you want it done, just hit start printing and slice and you're good to go. So we're going to select for printing, and you see in the bottom left we just got this bar up and it's slicing really quick. Larger files will take longer to slice, and so now you see that we've just popped it up. And so this is the V2, but we actually already have the V3 uploaded and sliced already. So we're actually going to load up the V3 leg. Okay, so moving on, we're basically done with this until we actually decide to hit print over here. We're going to go over these tabs in the upper right. So the first off again is temperature. And so this graph is linked with this set of radial bubbles, etc. So you can type in a number here, and you can actually hit enter, and it will go and it'll start heating up. Or you can just select from the drop-down menu whatever material we're using. So generally in the lab here we're going to be using ABS, which is 230 degrees Celsius. And so you can see in the upper right we've actually started some active movement on our table or our graph up here. And so again, this red line, this faded red line, is the target temperature, so what we want it to be, and this solid red line is what it is actually reading. So as you can see, it's going up, the needle is heating, which is exactly what we want. And so we also want to heat up our bed. The bed is usually the one that takes longer to heat up, so sometimes it's good to heat up the bed first and wait a bit. You can see it's gone up now on the top right. And this offset side over here is if we had a poorly calibrated temperature system, we would use this. However, the TAZ is perfectly able and capable of doing its own temperature calibrations, so we will not use the offset variable. Alright, we are going to leave the temperature to heat up for a bit before we start our thing. So we're going to go to the next tab, so control. So control is, again, the physical controls of this 3D printer. So yeah, X, Y, and Z. So hitting this right button will move the needle right, left, back on the bed, forward on the bed. And so, again, this is laterally, this entire system right here on the bed, and this Z value is vertically, so this is moving the needle up and down, etc. And so the bubbles below that are the distance they will go when you hit an arrow. Okay? And so these house buttons, or homing buttons, will bring the entire machine back to its homing positions. So in the case of the XY homing, it'll bring it to the front left of the bed, and the Z position will bring it all the way to the bottom. So the needle will almost be, or will be, in contact with the bed. And so this is if you're doing calibration or maintenance of the machine. And so this is pretty much necessary to move the bed out so you can take out the film, etc., or scrape off your prints. Moving on, we won't really talk about feed rate because that, again, that's a set variable in which we don't want to change at all. So we're moving on to tool here. So in the case of our kitty printer, we actually have 2 hot end needles. And so on the TAZ we only have 1, so we can only select the 1 hot end. But basically, this is where you will extrude and retract damaged filament or just prepared filament. If you're loading new filament, you want to hit the extrude button until it actually extrudes out the needle. Or if you've noticed a jam, you want to use retract to help you pull out the filament. And so you only want to use these 2 commands if it is heated up, the needle is at 230, or else the filament will not move. It'll actually just not move the motor at all because it will be a cold extrusion, and the machine prevents that itself. So you can set a custom amount to extrude, and usually I'll use 10 or 15 when I am loading new filament, etc. But 5 is good. Again, you can hit the extrude button multiple times, etc. So the select tool, again, on the kitty printer, you will have 2 options here, and basically you'll extrude from either or. On the right side, you can have motors off if you want to physically move the machine. So let's say you want to pull out the bed yourself or move the needle yourself just to get it out of the way. You'd hit motors off, and then the machine will let you do that instead of resisting you. Fan on and off. Now this is a cooling fan that is mounted near the tip of the needle, and so the machine will turn this on automatically. There's no real need to hit these, but you can just hit fan on and it'll start the fan. That's pretty much it for the control. Again, what you would use the control for is maintenance and physical movement. We're going to go on to the next tab, which is the G-code viewer. And so this is a tab that will only really be useful when you actually have a model loaded. And so what you're seeing right now here is the physical tool paths as interpreted by the slicer. So if we zoom in here, you can see basically these are individual lines which it will lay down filament on. And so this is how the printer works. It lays down lines of filament until it becomes an entire hole. And so it has the whole 3D model, basically. You take the slider on the right side, you can see upwards physically where it goes. And so this is useful for checking, A, this is the model you want, and B, if there's any slicing defects. Like, say you didn't want this giant brim that appeared. You realized, oh, you sliced it with a brim, you can go back and reslice the model. Otherwise, you can just leave it synced with job progress, and it'll show you a nice little graphed area of just where the needle's going, where it's going to be, etc. And so in the bottom right, you have various options to do this, so like center viewpoint on model, just centers the viewpoint. Pretty much, it's a useful tool to just see and make sure everything's working all right. Okay, moving on to the next one, we're going to the terminal. So the terminal is really only for diagnosing errors. Pretty much in general operation, you shouldn't be using the terminal because, hey, there's no need. So the one time you would really use the terminal is if, say, it wasn't connecting. It was just giving you errors up here, etc. You could basically see what error it was giving you, like, hey, is the printer turned on? Or maybe there's no connection to the USB port. Something along those lines. If you're really advanced and know exactly the G code to send, specifically to edit something, you can send it. But again, shouldn't really use that. Should all be directly sliced from the model. Alright, we're going to move on to the next one. And so, time-lapse. Hey, so if we have a USB webcam attached to a Raspberry Pi, we can give it a time-lapse option, actually. And if that USB webcam is attached and configured correctly on the Pi, you can actually see the webcam right here where this black bar will be on the control side. So, say you're across campus connected to the school Wi-Fi, you can see your objects. However, time-lapse, occasionally we'll use this for promotion purposes, but again, really no need to use it, and it will take up lots of memory on the card. History is an important bit, and so basically you have all these sorting bits, and so you can see the history of all the prints going back a long time. And you can see actually there's a lot more cancels or failures, as it calls them, than successes. That's generally what it ends up being. We've gotten a lot better recently, so it still has history for our dark past in 3D printing. But you can always just sort only by successful prints, and you can see, hey, this is the name of the file, this is the date it was printed on, this check mark means it was successful, this is exactly how long it took to print, so you can gauge again how long another print of the same kind of thing is going to be, and then the filament usage, which is actually really important to us. So you can see we used about 4 meters of filament, or 27 centimeters cubed of the tool. And so this helps us gauge how much filament we have left, and hey, if we can actually print something. Because, you know, if it takes an entire roll, which something shouldn't, then it can't be really printed. Moving on, there are additional tabs actually down in here, in the top right again. So if you go here, we have an STL viewer, and this is an add-on plugin, and basically what it allows us to do is choose a file over here, so our TriLeg v3, and it'll give us a 3D render. And so I've just clicked in and click and drag, and you can move and look, hey, this is the exact model I want to use, and this is correct, this isn't some huge error, and it's also what I want to print. You can render it as smooth or flat. Flat is usually a better one. Pretty much the other bits are kind of esoteric and not exactly as helpful. You can just see that as points. So generally just leave it as flat. And so this is just, again, to make sure a model you've uploaded is the exact model you want to use. Alright, that goes over pretty much every single tab that a general user will use. There's also the settings and system tab up here, or the login. But unless you are really proficient with this, and you've talked to one of our other techs, you really shouldn't touch settings, etc. Or system. Well, system, pretty much shut down, reboot, restart Octobin. That can actually be useful, again, with updates you saw in the upper right as we started this video. Or pretty much just to restart the Pi if it's running slow. So, we're going to go back to our temperature now. And hey, alright, we're heated up. Our solid lines are next to the pastel lines, and we are ready to print. So, over here in our state, we have our TriLeg already loaded up. Our machine is leveled and ready. We're going to hit the print. And you can see now we have a print time. We have a print time left. And how long it is in the file. Approximately what filament it's going to use. Approximate total print time. And we're good to go, everyone. That's pretty much it. The only other thing is for the kitty type printer is you will always want to heat it up manually. Everything else is pretty much the exact same. Just heat it up manually before you start the kitty printer, and you're good to go. Alright, everyone. Have a good time printing.